Hey everyone, and welcome. If you're a Java developer, you probably type the word string dozens, maybe even hundreds of times a day. It feels so basic, right? Fundamental. But what if I told you there's a whole hidden world of memory optimization, performance traps, and even security issues lurking just beneath the surface of that simple word? Today, we're going to pull back that curtain. We're diving deep into what every professional developer really needs to know about Java strings. Let's get into it.
Think about it. You've probably typed this line or something like it thousands of times. String s equals hello. It's muscle memory. But have you ever stopped to ask what the Java virtual machine is actually doing in the background? It's way more fascinating than you might think. And honestly, understanding it is a huge key to writing cleaner, faster, and safer code.
So let's kick things off by taking a closer look at the object we all think we know so well. We're about to peel back the layers on the deceptively simple string, and that very first layer, well, it reveals its most important secret.
Okay, here's the official definition. A string is an immutable sequence of characters. Now, I want you to focus on that one word, immutable. If you take only one thing away from this whole explainer, let it be that word, immutable. It is the secret that unlocks everything else we're about to talk about. So, this immutable rule is what lets the JVM pull off some incredible magic to be more efficient. Let's explore how this one simple rule leads directly to a special, highly optimized area of memory called the string pool.
Let's be crystal clear about what immutable really means. It means that once a string object is created in memory, say with the value hello, that specific object can never ever be changed to hello world or anything else. It's set in stone. This is a powerful guarantee because it lets the JVM safely share these string objects all over your application without ever worrying that one piece of code will mess things up for another.
Which brings us to this little piece of code right here. We've got two different string variables, A and B, and we're assigning both of them the exact same value, hello. Seems straightforward, right? But what's really happening in the computer's memory? So here's the million-dollar question. If we use the double equals operator, which you'll remember, checks if two variables are pointing to the exact same object in memory, is this going to be true or is it going to be false? Take a second. What do you think? And the answer is yes, it's true. This is the string pool in action, and it's brilliant. Since strings are immutable, the JVM is smart. It says, hey, I already have a hello string sitting in my special pool of strings. I don't need to waste memory creating another one. I'll just make both A and B point to that same single object. It's a fantastic way to save memory.
Okay, so we've established that strings can't be changed and that they live in this special pool. This isn't just theory. It has really important practical consequences for two of the most common things we do with them all the time, building new strings and comparing them.
And this right here is a classic Java pitfall. It's probably one of the most common interview questions out there. Think of it like this. The double equals operator asks, are these two variables pointing to the exact same house on the street? The dot equals method, on the other hand, goes to each house, knocks on the door, and asks, are the actual characters inside the same? When you're comparing strings, 99.9% of the time, you care about the content, not the memory address. So dot equals is almost always what you want.
And that brings us to maybe the biggest performance trap of all. Come on, admit it. We've all written code like this. You're in a loop, you're building up a string, and you just use the handy plus operator. It looks so clean and simple, but because strings are immutable, what's happening under the hood is an absolute performance disaster.
The result is O of n squared, or quadratic time complexity. And if you're not up on your big O notation, let me just say, that is really, really bad. Imagine you're writing a novel. With this method, every time you want to add a new sentence, you have to throw away the entire manuscript and retype it from page 1 plus your new sentence at the end. It's crazy. For a loop that runs 1,000 times, you're creating almost 1,000 temporary useless copies of your string. It just burns through memory and CPU cycles.
So if using the plus sign in a loop is the villain of our story, who are the heroes? Well, fortunately, Java gives us the perfect tools for this exact job. It's time to meet the mutable builders, StringBuilder and StringBuffer.
The solution is just so much better. You use a class that was designed specifically for this, StringBuilder. You can see it right here. We create just one StringBuilder before the loop starts, then inside we just use the .append method. This tiny change in how we write the code makes a world of difference.
And that difference is linear time complexity, ON. It is a massive, massive improvement. So why is it so much faster? Well, you probably guessed it. StringBuilder is mutable. It's not creating a new object on every single loop. It's working with the same underlying block of memory over and over again, just adding characters to the end. It's incredibly efficient.
This table sums it all up beautifully. You've got your classic string, immutable, not meant to be changed, perfect for constants. Then you have StringBuilder, it's mutable, which is awesome for building strings, but notice that it's not thread safe. That's where its twin, StringBuffer, comes in. It's also mutable, but it's synchronized, which makes it safe to use with multiple threads. So the rule of thumb is simple. String for constants, StringBuilder for all your single-threaded string building, and only pull out StringBuffer when you absolutely know you need that thread safety.
All right, let's shift gears. Time for a lightning round. These are the pro tips and common pitfalls you need to know to write better code and, let's be honest, to absolutely ace your next technical interview.
First up, interview traps. They are almost guaranteed to ask you about equals equals versus dot equals equals. Be ready for it. Also, always be prepared to handle nulls to avoid that dreaded null pointer exception. And hey, if you really want to show off, mention the old substring memory leak that existed in versions before Java 7 Update 6. It used to be that the new substring would hold a reference to the entire original character array, which could be a huge memory hog. Mentioning that shows you've really done your homework.
Okay, performance tips. We've hammered this one home, but I'll say it again. Use StringBuilder in loops. Don't use StringBuffer just in case. That synchronization has a performance cost, so only use it when you actually need it. And here's a deep cut for you. The intern method. It lets you manually add a string to the string pool. If you know you're creating tons of duplicate strings at runtime, this can save memory, but use it with extreme caution, because the act of interning has its own performance overhead.
And finally, let's talk security and data integrity. This is huge. Never, ever handle sensitive data like passwords in a string. Why? Because strings are immutable and live in the pool. You have no control over when they're erased from memory. That password could be sitting there for a long time, just waiting for an attacker to find it in a memory dump. The correct way to handle passwords is with a character array, a char array. That way you can explicitly wipe the data from memory the second you're done with it, leaving no trace behind. Oh, and another thing, always specify a character set like UTF-8 when you're converting strings. Trust me, it will save you from some very strange and hard-to-find bugs.
So it turns out the humble string, one of the first things we all learn in Java, is hiding this whole world of complexity. It's fascinating stuff. And it kind of makes you wonder, right? What other simple code that you write every single day is worth a second look? What other hidden stories are waiting to be discovered in your own codebase? Thanks for joining me.